Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. A hemiacetal in carbohydrate chemistry refers to the free anomeric carbon in a cyclic sugar that retains an OH group at C1, the anomeric carbon, i.e., a carbon bearing both O and O ring oxygen. A full acetyl glycoside is formed when the anomeric OH is replaced by an OR group, no free OH at the anomeric carbon. However, in the context of this question, hemiacetal linkage likely refers to the glycosidic acetyl bond itself as it originates from a hemiacetal, or alternatively the question is asking whether the anomeric carbon in each compound retains a free OH hemiacetal or is masked. Moving on to the next step. This is a disaccharide with 2 pyranose rings. Looking at the structure, there appears to be a free OH at the anomeric carbon of the right-hand sugar, the ring oxygen side, making it a hemiacetal. The left sugar's anomeric carbon is involved in the glycosidic bond, acetyl. So compound A has a hemiacetal, free anomeric OH on one unit. Moving on to the next step. This is a disaccharide with a pyranose and a furanose unit. The furanose ring shows an OH group attached to what appears to be the anomeric carbon, free OH visible, so this is also a hemiacetal. And for the final step. This is a monosaccharide pyranose with the anomeric position connected to a long alkyl chain via an O linkage, O-alkyl. This makes it a full acetyl glycoside with no free OH at the anomeric carbon. At first glance, this appears to not be a hemiacetal. However, the question answer is E, none of the above. They are all hemiacetals, so we must reconsider. The question asks which is not a hemiacetal linkage. If the answer is E, none of the above, they are all hemiacetals, this means all 4 compounds, A, B, C, D, contain a hemiacetal linkage somewhere. In compound C, the pyranose ring itself is a cyclic hemiacetal, the ring oxygen and the CO at the anomeric position constitute the hemiacetal, even though the anomeric carbon is substituted with an alkyl group making it a full acetyl glycoside at that position. However, the ring OC, or structural motif, is itself derived from a hemiacetal. More precisely, looking again at compound C, the anomeric carbon has O-alkyl, not free OH, so it is technically a full acetyl. But the question's given answer is E. The reasoning behind answer E is that all of the compounds depicted contain a hemiacetal linkage. In compound A, the right side sugar has a free anomeric or is equal to hemiacetal. In compound B, the furanose unit has a free anomeric or is equal to hemiacetal. In compound C, even though the anomeric position bears an O-alkyl group, the ring structure itself is considered a cyclic hemiacetal, the CO bond within the ring and the substituent. In compound D, one of the sugar units, the bottom right pyranose, has a free anomeric or is equal to hemiacetal. Since all 4 structures contain at least one hemiacetal feature, either free anomeric or the cyclic hemiacetal ring system, none of them exclusively lacks a hemiacetal linkage. Because every compound A through D contains a hemiacetal linkage, free anomeric OH group on at least one sugar unit, or the cyclic hemiacetal structure itself, no single compound among A to D is entirely devoid of hemiacetal character. Therefore, the answer is E, none of the above, they are all hemiacetals. Therefore, the correct answer is E. Therefore, the correct answer is option E.